In the first part of Module 1, Lesson 6, we learned how to find the least common multiple by listing the multiples of each number. 3 times 1, 3 times 2, 3 times 3, 4 times 1, 4 times 2, 4 times 3, until we found the smallest, least common multiple in the list. Next, we went on to learn how to list factors of numbers. We did it by making squares. So we found all the factors of 4, all the factors of 8, and so on. So we're going to use that last technique to help us learn how to find the greatest common factor, which means what number, what factor goes into both 20 and 12. And the reason I'm stressing the word is a lot of students go, oh, I always get GCF and LCM mixed up. Well, if you know your vocabulary, you shouldn't. Factors are numbers that go into other numbers. So 6, the common factor, or the factors are 1, 2, 3, 6. 1 goes into 6, 2 goes into 6, 3 goes into 6, and 6 goes into 6. Those are the factors of 6. So in this section, we're going to try to find factors that are common to a list, and we want the biggest one this time. So rather than start from the smallest and circle the smallest like we did for least common multiple, we're going to start at the end of the list and circle the largest, hence the name greatest common factor. So you can't just think of it as letters, you got to say it. This is greatest common factor. So we're looking for the largest number that's common to both of these numbers. And it's a factor when it goes into them evenly. So for me, the easiest way is I like to just list the factors until I meet in the middle. So for instance, for 20, I know the first factor is 1 times 20. And I put 20 out here. And then I just go down the list until I meet in the middle. So 2 goes into 20 and it goes in 10 times. 3 doesn't go into 20. The trick for that is 2 plus 0 is 2, and 3 doesn't go into 2. So you add the digits. If 3 goes into the digits, 3 goes into the number. And 2 plus 0 is 2. 3 does not go into 2. 4 does. And it goes in 5 times. And see what I mean by meet in the middle? There's no other numbers to try. So that's why I always do it in order, then I'll never miss a set of factors. Once you meet in the middle, you're done. Now let's do the same thing with 12. 1 times 12. 12 is even, so that means 2 goes into it, and 2 goes into it 6 times. 3 also goes into 12 4 times, and look at that. I met in the middle, so I know I've listed every single factor because I always did them in pairs. 1 and 12, 2 and 6, 3 and 4 until I meet in the middle. Then I start at the end of the list and I circle the largest, greatest common factor. 20, nope, not in this one. 10, nope, not in this one. 5, nope, not in this one. 4, ding, 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 ding. So there we have the GCF is 4. So that is the largest number that divides evenly, because G means largest, into both 20 and 12. So what is the greatest number of groups they can make? 4 groups, and have the same number of each in each group. Okay, so there's only 2 on this section, so I'm going to let you do the next one. This one has 3 numbers, so you have to expand out 3 numbers. 32, list all the factors, starting doing pairs till you meet in the middle. 24 and 16. See if you can find the greatest number of arrangements. So go ahead and shut off the video, and then join me when you're done and we can check your work. Okay, so using the technique above, 1 times 32 is 32. 32 is even, so 2. And if you don't know how many times 2 goes into 32, just divide it out here on the side. 2 goes into 3 once. 1 times 2 is 2. Draw the line, change the sign. 2 goes into 12 6 times. So 16 goes here. Add the digits. 3 plus 2 is 5. That means that 3 does not go into 32 because 3 doesn't go into 5. So you add the digits for the test for 3. 4 does. 4 times 8 is 32. So all we have to do to meet in the middle is test 5, 6, and 7. So 5 doesn't go into 32 because it doesn't end in 0 or 5. 6 doesn't go into 32 because 6 times 5 is 30. 7 doesn't go into 32 because 7 times 5 is 35. So there's our list. And then next we have 24. So we have 1 and 24. And 24 is even. So that means 2 goes into it. Cut 2 in half 1, cut 4 in half 2. So that means 2 times 12. Add the digits. 4 plus 2 is 6. That means 3 goes into it because 3 goes into 6. And 3 goes into it 8 times. 4 goes into 24 6 times. And so the only number I have left to check until I meet in the middle is 5. 5 does not go into 24 because it doesn't end in 5 or 0. So there's all my factors for 24 and 32. So one more number left, 16. So 1 times 16 is 16. 16's even, so it's divisible by 2. 2 times 8, and then 4 times 4, which you don't have to list twice. And because it's 4 times 4, we already met in the center. So just start going down the list. It doesn't matter which list you pick. Just pick one and start looking for that. 32's not in either of these. 16's here and here, but it's not here. So it can't be common if it's not in all three. And then all of a sudden, here it is, 8, 8, and 8. So the GCF of 32, 24, and 16 is 8. That is the greatest number of arrangements I can make that use all the flowers. So I can make 8 arrangements, greatest common factor. Okay. So with least common multiple, we multiply to get the numbers. Hence the word M for multiple. 3 times 1, 3 times 2, 3 times 3, 3 times 4. For factor, greatest common factor, we list all the factors of each number. All the numbers that go in evenly, and because it's greatest, it tells us to start at this end of the list and circle the largest. So that's called the listing method. I like the listing method when the numbers aren't too large. I think it's great. But I'm going to show you another method on the next page. So we're not going to do this next example. I looked at it and I don't like it. So skip over to student page D. And here's an alternate method. I love this method, especially when the numbers are larger. I mean, you could do 24 and 60 and do the listing, but this is having you do GCF and LCM, which your test does, and so does your final exam. So it's kind of nice to have one method that will give you both. So if I didn't do this method that I'm going to show you, then you'd have to do all the factors for each one and then all the multiples for each one. And the common multiple can get pretty large when you're trying to find a number 24 and 60 goes into. So this is my preferred method when one or both of the numbers is larger. So I make what's called a prime factorization tree. So I pick any two numbers and multiply to give me 24. So I started with 4 and 6. Neither of these is prime. They both have numbers other than 1 in themselves that go into it. So I break it down again. 4 turns into 2 times 2. Now both of those are prime, so notice I circled them. 6 breaks down into 2 and 3. Both of those are prime, so I circled them. So the prime factorization of 24 is 2 times 2 times 2 times 3. And I always tell students on tests, you can check this. All you have to do is go down the list, and all those prime numbers should give you back the original number. 2 times 2 is 4, times 2 is 8, times 3 is 24. Ding, 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 ding. Right back to the original number. Then we do the same thing with the second number, 60. So 60 is 10 times 6, or you could have used 2 times 30, or you could have used 3 times 20. It doesn't matter which 2 you start with. Students always think, oh, I don't know which pair to start with. Doesn't matter. We just don't use ones, so you wouldn't want to do 1 and 60. But any other number that goes into 60 is fine. So 10 and 6, 10 is 2 times 5. Now they're both prime, so I circle it. 6 is 2 times 3. Now they're both prime, so I circle them. So the prime factorization for 60 is 2 times 5 times 2 times 3. So then I make what's called a Venn diagram, and I like to put the numbers right on top of each other. It makes it easier to see and put them both in order. So this is 2 2s, a 3, and a 5. 2 2s, a 3, and a 5. To find the common factors, we just go down the list and circle anything that's in both lists. There's a 2 in both lists, there's a 2 in both lists, and there's a 3 in both lists. So we're going to label this one 24, and we're going to label this one 60. So whatever I have circled goes in the common region of the Venn diagram. So there was a 2, a 2, and a 3. And one of the mistakes I see students make on this is they go 2, 2, 2, 2, 3, 3. No, that means there's 4 2s common. There are not 4 2s common. There's 2 2s and a 3 common. So I bring this down and put 2 2s and a 3. And then I say, what's left from 24? 2 2s and a 3 already there, so what's left for the 24 side is a 2. And then I do the same thing over here. 60 is 2 2s, a 3, and a 5. I have the 2 2, I have the 3, so 5 what's left over. Because these numbers should, when I cover up the other side, 60 should have all the numbers that are here. Same thing here, when I cover up this other side, 24 should have all the numbers that are in 24's list, 3 2s and a 3. So these are the common ones, always in the center. The ones that aren't common go outside. So this is why it's so beautiful. This, when I multiply this out, is my GCF. So 2 times 2 times 3, 2 times 2 is 4, times 3 is 12. So the largest number that goes into both 24 and 60 is 12. 12 goes into 22 times, 12 goes into 65 times. And for the LCM, you write every number you see. And this is another spot where students mess up. They write every number they see up here. No, you write every number you see in the circles. So I see a 2, a 2, a 2, a 3, and a 5. So I just go left to right and write every number I see. So 3 2s, a 3, and a 5. And then I go down the list, and when I'm multiplying, it doesn't matter you know what order. Remember, multiplication is commutative. So you can go left to right, you can do these 3 together and those 2, whatever you want. So I'll just go left to right on this one. So 2 times 2 is 4, times 2 is 8, times 3 is 24, and then I have to go 24 times 5 to get the final answer, 20, carry it 2, 10 plus 2 is 12, and there is my LCM. And remember, the name should tell you if you've done it right. Factor means a number that goes into both numbers. A factor divides evenly. Does 12 divide into 60? Yes. Does 12 divide into 24? Yes. A multiple, least common multiple, is a number that they both multiply into. 24 times 5 is 120. 60 times 2 is 120. So just by saying the names, not the letters, it will help you keep these straight. So a factor divides into them, and a multiple, they have to multiply to get to it. 24 multiplied by 5, 60 multiplied by 2. And that way you'll never get them mixed up. Because I think students get so involved in the acronym, they don't even know what the word means. So say it out loud. It's the greatest factor, a number that divides in. It's the least multiple, the smallest number they multiply into. Okay, so let's try some. I think we got 5 of them over here to practice on. So how about we do the first 3, and then you can do the next 2 to make sure you got this, because this is just a great method when the numbers are largish, have a lot of factors. Like, do you know how long it would take to find a number that 24 and 36 both multiply into? But by using this method, once you get the trees done, you're there. Okay, so let's start with a tree for 24. So 24, and you can pick any number you want to start. So I'm going to start with 4 and 6. I think that's probably what most people would pick. And then neither one of those are prime. They can both be broke down again. So 2 times 2, both prime, circle them. 6 is 2 times 3, both prime, circle them. So I'm going to put 24 here and write 2 times 2 times 2 times 3. So it's easiest when you have them right on top of each other and you can see that. Then we do the same thing with 36. With 36, we could do 6 and 6. And neither of those are prime, so we keep going, and they both break down into 2 times 3, which are both prime, meaning they don't break down any further. So 36 would be 2, 2, 3, 3. And remember, if you're not sure you did it correctly, all you have to do is multiply them out and you should get the original number back. 2 times 2 is 4, times 3 is 12, times 3 is 36. 2 times 2 is 4, times 2 is 8, times 3 is 24. So they'll always give you the original number back. So now it's time to inspect and see what numbers they have in common. They have a 2 in common, so put a 2 down here. They have another 2 in common, so put another 2 down here. And they have a 3 in common, so put a 3 here. So I already know what my GCF is. When I multiply those out, that will be my GCF, because it's called greatest common factor. It's what they have in common. A 2, and a 3. So we would write 2 times 2 times 3. 4 times 3 is 12. So then I asked myself, a factor is something that divides evenly into a number. Does 12 go into 24? Yes, 2 times. Does 12 go into 36? Yes, 2 times. And all students would have to do is exactly that to know that they found the right one. Okay, so now we need to fill in the list. So 24 is the circle, so when I cover it up, I need to have all the numbers for 24. So I have a 2, and a 3, so I need to add that uncommon 2 over here. Then I do the same thing on the other side. So I need to have 2 2s and 2 3s. So I'm missing that 3 that's not common, so I put the 3 outside here. And then when I cover it up, all the numbers from 36 should be there. So 36 is 2233, 2233. 24 is 2223, 2223. And then to get the LCM, remember I just multiply every number I see, not up here, in the circles. So it's a 2, a 2, a 2, a 3, and a 3. So 2 times 2 times 2 times 3 times 3. And sometimes I like to group them because I can do it easier in my head. 2 times 2 is 4 times 2 is 8. 3 times 3 is 9, and I know 9 times 8 is 72. So 72 is the least common multiple, which means the numbers multiply into it. 36 multiplied by 2 is 72. 24 multiplied by 3 is 72. And I don't do this part. So we're just working on GCF and LCM right now, one thing at a time. Okay, so see, that's pretty fun. The trees take a little teeny bit of time, but once you get the trees done, the two answers are so easy. What's common? Greatest common factor. Multiply them out. LCM, write everything you see in the two circles. Okay, so now we have a couple with smaller numbers. Just as easy. So 8 is 2 times 4. Okay, I got to remember to keep looking up and make sure I'm on the paper. And then 2's prime, so I circle it, and then 4 is 2 times 2. So I can see that 8, let's put it over here, is 3 2's. 2 times 2 times 2. Okay, next we have to do 12. So 12 is, we could do 3 times 4 or 2 times 6, doesn't matter which one, I'll just do 2 times 6. And 2's prime, so circle it, and then 6 is 2 and 3. So then I go up here and I write 12 as 2, 2, 3. And usually the only time I see students miss this, besides getting LCM and GCF mixed up, is they don't take the time to circle the primes. Always circle the primes. Then it makes it so easy to see which numbers you're using. Because if you don't circle them, then students will pick the 6 or pick the 4. You want to circle all the primes so you don't accidentally pick any of the wrong ones. Okay, so we're looking for the GCF. So 2 is in both, and another 2 is in both. So this would be 2 times 2. That one's easy. 4. So remember, a factor is a number that divides evenly into both. Does 4 go into 8? Yes, 2 times. Does 4 go into 12? Yes, 3 times. So that's what a factor is. Okay, so next we have LCM. So we have to go to each list. So on 8, what are we missing? We're missing the 2 because these two 2's are already in, so we need that third 2. On 12, what are we missing? We're missing the 3. We got the 2 2's, so now we need the 3. And you can test it. Are these all the factors of 8? Yes, 2, 2, 2. Are these all the factors of 12? Yes, 2, 2, 3. So now we're ready for the LCM. 2, 2, 2, 3. 2, 2, 2, 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. Or you could do 4 times 6. 2 times 2 is 4. 2 times 3 is 6. And get 24 as well. Okay, let's do one more and then you guys can try the next two on the next page. That's all we're going to do in this packet are just those two. And then we're going to stop. Okay, 15 nice, easy factors. 1 second, let me turn off my phone. It's jingling. Of course, nobody calls all day until I start making videos. Okay, so for 15, we have 3 times 5. And they are miraculously already both prime. Done. And then we have 14, which is 2 times 7. Same. Both prime. Done. None of those 4 numbers can be broke down. So 15 is 3 and 5. And 14 is 2 and 7. Uh-oh. I don't see any number to put in here because this is the number that's common to both. 2's not common to both, 7's not common to both, 3's not, 5's not. So what do you guys think that would be? What number goes into every number in the world? 1. So if there's nothing common, they always have 1 common. 1 goes into 15 times. 1 goes into 14 times. So if nothing's in your 2 lists, that's your answer, just 1. Because 1's common to every set of numbers. So the GCF is just 1. The LCM, so we have to write what's missing. So from 15 side, what's missing? The 3 and the 5. And 3 times 5 times 1 is 15. And what's missing from 14 side? The 2 and the 7. Because 1 times 2 times 7 is 14. So I have to go all the way across to get my LCM. So 3 times 5 times 1 times 2 times 7. So that's going to give me 15 here times 14 here. Actually, I could have done that easier. I just see that now. 15 times 2 is 30. 30 times 7. 3 times 7 is 21, so it would be 210. That's okay. It's good to show our work. So let's do 15 times 14 down here and see if we do indeed get 210. So 20, carry our 2, 4, 5, 6. Bring our 0 down. 1 times 5 is 5. 1 times 1 is 1. 0, 11. Ding, 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 ding. I love it when we get the right answer. So 210 it is. Woohoo! So the GCF, a number that divides evenly into both numbers, is 1. The LCM, 210. I'm going to make this a little bit smaller. I see that I'm having to move my paper back and forth again. Okay, so you guys feel like you're ready? Say yes, say yes. Okay, the next 2 are yours. And like I said, that's where we're going to stop in this packet. We're not going to do the multiplying thing because most students wouldn't do that on a test anyway. So you can leave these off. You can leave the table off on the bottom and the question on the next page. We're going to stop right here. So go ahead and turn off your recording and see if you can find the GCF and LCM for 15 and 18, and then again for 15 and 21. And then come back and join me and we'll check our answers. Okay, so tree time. So 15, 3 and 5. And then I'm just going to put 15 here and write 3 times 5. And then we have 18. There I am, off the paper again, sorry. 18. I wish you guys were in my class and you could scream at me and say, hey, your paper's not showing. So 18 is 2 times 9, or you could have done 3 times 6, either one. And then 9's not prime. It can still be broke down. So it looks like 18 is going to be 2, 3, and 3. So remember, this is always your common. That's why it's called greatest common factor. So what factors or factor do they have in common? And you can easily see here the only thing they have in common is a single 3. So I put 3 here. And then I cover up this side, and all the numbers for 15 need to be in 15 circle. So I got the 3, that means only 5 is missing. And do I do the same thing here? 2, 3, 3, I got the 3, so I need a 2 and a 3 here on this side. So I got the 3, I need to add 2 and 3. So we already know the GCF, no work involved. It's always what's in the center, what's common, nothing to work out. So it's 3. And then I pause a moment to make sure my answer makes sense. Does 3 go into 18? Yes, 6 times. So 3 is a factor of 18. Does 3 go into 15? Yes, 5 times. So 3 is a factor of 15. And then LCM, remember, just all straight across. 5 times 3 times 2 times 3. So 5 times 3 is 15. Double 15 and you get 30. 30 times 3 is 90. And if you're not sure your work's correct, then go backwards. 3 times 2 is 6. 6 times 3 is 18. 18 times 5. We can work that out and make sure that comes out to be 90. So 40, carry our 4, 5, 6, 7, 8, 9. There we go. We just verified. So how'd you guys do? I hope, well, this is a fun method. I love it. I think it is just the greatest method in the world, especially when you're asked to find both, because producing 4 lists takes forever. But this, after you get the trees done, piece of cake. Okay, so next we have 15, which we've already done previously. That's 3 and 5, both prime. So we write 15 here, 3 times 5. And then for 21, it's 3 and 7. Also, again, both prime. So we stop on the first step and we write 21 equals 3 times 7. So easy to see what the GCF is. What's common to both? The 3. So my GCF is 3. And I always label it right away so I don't forget the name of it, because sometimes students get thrown on the test when they ask for LCM first. They'll put 3 there. So I label it GCF. It's the common factor. That way I never get it wrong. And 15 is missing the 5. And 21 is missing the 7. So I know my GCF is 3. And my LCM is going to be 5 times 3 times 7. Multiply every number you see. So that looks like 15 times 7. So 15 times 7, 35, carry our 3, 7, 8, 9, 10. Looks like 105. And then if you want to check your work, go backwards. I do it all the time, especially on a test. 7 times 3 is 21. 21 times 5, let's see if I get 105. 5, 10, boom. So then I can, without a doubt, know that that answer is correct. Okay, so that's all we're going to do on this section. This is just kind of a weirdo thing. It takes a lot of time and you don't really need to know it for any other classes. So I'm just going to stop there for lesson 6. So we're officially done with Module 1 notes. So the things you want to make sure you have completed for your test is you want to make sure you have all 6 sections of your notes completed, lesson 1 through lesson 6. You want to make sure all your ALEKS homework for Module 1's done, lesson 1 through lesson 6. You want to make sure you've taken your quiz, which covers lesson 1 through lesson 3. And you want to make sure you've done your practice test. The practice test is on the date or the on your Canvas homepage right after this one where you found the videos for this. The next one on your Canvas homepage has your practice test to get ready for the test. It has videos for the practice test, and it has the worked out solutions. So you can use whichever one you want. If you don't want to watch the videos and you want to do the practice test yourself and just check it with the solutions, you can do that. But all of those things need to be done before you take your test. So your notes, and they have to be scanned to me. The due dates are in Canvas. All of your Alex homework, the homework you do not have to scan to me because Alex records it and sends me your score. Your lesson 1 through lesson 3 quiz, and your practice test. And I recommend you do the practice test yourself, all by yourself, then check it with the key that's on the tab right after this one. And if there's anything you don't understand on it, then watch a video on it. But I don't think you should have to watch a video on the whole entire practice test because you're trying to get ready for the test. So you want to do the work yourself and then check in Canvas at the answer key to make sure you got it all correct. Because that's how I make the tests off the practice tests. Okay, well, good luck on that first test. I look forward to seeing your great scores. See you in chapter 2. Bye.